So we've just talked about different ways that we can approach factorising what I nickname HQs, so quadratic expressions where there is a non-unitary squared term, or ways that we can solve non-monic quadratic equations. Generally speaking, if you're wanting to factorise, the best way I find to do it is to split up that middle term. You can do it in the old-fashioned way that I learned when I went to school, and that will work if you don't have too many factors flying around, too many different possibilities. What we found in our previous video was that in order to split up that middle term, the sort of magic two numbers that you want, you need them to multiply to give AC and to add to give B. Now, in this particular example, A was 14 and C was -3. So we wanted two numbers that multiplied to give -42. And B was 19, so we wanted them to add to give +19. We came up with +21 and -2. And of course, it doesn't matter which order you write them in. You can go with your +21x here, -2x here, etc. And then you continue on from there using grouping. Now, that's all very well if you can come up with those two numbers. Practice does certainly help. You get a feel for how you're going to find those various factors. You can also go through it systematically, so you can start thinking about factors of 42. You've got 1 and 42, you've got 2 and 21, etc. Obviously, if you're multiplying to give a negative, one of them will be positive, the other one will be negative, and the difference in magnitudes will be this number here. That kind of thing, you get a bit of a feel for it once you've done a few. However, what happens if you get into a situation like this example here, where really your factors involved, regardless of which method you're going to use, are going to be quite considerable in their possibilities. If you try to do it in the way that I was taught back at school with your 16, you could have 16 and 1, or 8 and 2, or 4 and 4. Factors of -135. Okay, well, 135 is actually 3 cubed times 5. So just imagine all your different possibilities there, also bearing in mind that one of them's got to be positive and the other one's got to be negative. That is going to be a right mess. You don't want to do it that way if you can get away with it. So probably what you would want to do here if you wanted to factorise would be to split up that middle term. However, also, this one is going to be genuinely tricky because you multiply to give AC. In this case, you want to multiply to give -2,160 and to add to give B, and you want to add to give 42. Imagine all the possibilities there. That is a bit of a mess, all right? So how are we going to deal with this? What are we going to do? All right? And this is where a bit of knowledge about our sum and product of our roots is going to help us. Okay, so we're faced with a bit of a difficult situation. We're trying to find two sort of mystery numbers that multiply to give -2,160 and add to give 42. We do know that one of them is going to have to be negative and one's going to be positive, and we do know that the difference in magnitude between them is going to be 42. We might be lucky enough to come up with the correct numbers. However, what happens if we can't? Now, here is where we're going to put into play some of our previous work that we did on monic quadratics. What we're actually doing here is this is the product of our two numbers and this is the sum. What did we find in a previous video we had as an equation for a situation where we want two numbers to be a certain sum and a certain product? We found that that was the same as solving a monic quadratic in the form x squared minus the sum times x plus the product equals 0. So in essence, what we're doing is we're solving a quadratic equation in order to split the middle term of a genuinely difficult, hard equation. All right. Now, how do you solve that? Well, you solve that by using your quadratic formula. And your quadratic formula in this case, because A happens to be 1, your X values, in this case, actually, I would prefer to go with Y, to be honest. So let's rewrite it as Y so that we're not going to get confused with our original equation, which was in X. So what we're wanting is that the solutions are going to be negative B, so it's your sum, plus or minus square root B squared, so your sum squared, minus 4 times A, which is 1C. So 4 times your product over 2A. How are we going to use that to help us? Well, we're going to use it as follows. All right, so we're faced with a situation where we have a genuinely tricky, harder quadratic, and we're trying to find those magical 2 numbers that will divide our X term in such a way that we can then use grouping to factorize. I've reminded you of the fact that if you have a monic quadratic in Y, it has the general formula y squared minus the sum times y plus the product equals 0. So this is, in fact, if we can solve this for y, this will actually tell us the 2 answers that we need here. Now, when we get to this point and we're trying to find our 2 numbers, what we're in essence doing is solving a monic quadratic equation. We could, if these numbers are relatively simple, factorize this, use our null factor law and go from there. If it's really tricky, we could use our quadratic formula for this, in which case, if we were to do that, our negative b is actually going to be positive, the sum that we're looking for, plus or minus square root b squared, well, negative sum squared is the same as sum squared, minus 4 times a, which is 1 times c, which is the product, all over 2a, which is 2. Yes, you can do that. However, it's interesting to think about it in this way, and it's actually a lot easier to work with more tricky numbers this way. Your 2 solutions, y1 and y2, so you've got y1 here, and there's y2 here. There will be a midpoint halfway between those. That's what a midpoint is, all right? And let the distance, that doesn't look equal, but it's meant to be equal. So obviously y1 is this midpoint minus d, and y2 is this midpoint plus d. What is the midpoint going to be? Well, the midpoint, if we're thinking about this here, it's going to be the sum divided by 2. Now let's have a look here at this. If I'm going to multiply my y1 times my y2, I'm going to get m minus d times m plus d, which of course is a difference of 2 squares, m squared minus d squared. And this, of course, is your product. So to work out what d is, d squared is m squared minus your product. Because we're going to be adding it and subtracting it, it's perfectly reasonable just to take the positive square root here. So our little d is a square root of m squared minus your product. And of course, bearing in mind that our first solution, our first sort of magic number, so to speak, is going to be our m minus d, and our second solution is going to be our m plus d. By the way, you can also find this information by doing y1 plus y2, and you get 2m all right, because you get m minus d plus n plus d. So obviously m is the sum divided by 2, and my corgi's getting very excited about that in the background. All right, so let's actually do it for this example here. We said that we were looking for two numbers whose sum was 42 and whose product was negative 2,160. Now, obviously trying to do that by hand would be really tricky. We don't want to be doing that. So let's use this information, these new rules, and see how we go. So obviously m is going to be our sum divided by 2, which is just 42 divided by 2, or 21. Our d is just going to be the square root of m squared minus the product. We've already worked out our m, so square root of 21 squared minus negative, so we're going to be adding 2160. So that's going to be the square root of 2,601, which is 51. Okay, so now we can find our y1 and our y2, our sort of magic numbers, our useful numbers to divide up this middle term. So y1 is m minus d, so it's going to be 21 minus 51, which is negative 30. Our second value will be m plus d, which of course is 21 plus 51, which is 72. You should be able to reassure yourselves that those two numbers add to give 42 and they multiply to give negative 2,160. Right, now we're finally ready to factorise this tricky quadratic by splitting up that middle term. It doesn't matter whether you write 42x as negative 30x plus 72x or 72x minus 30x. It really doesn't matter. So let's do it here. So 16x squared plus 42x minus 135. I'm going to write the 72 first, 72x, minus 30x, minus 135. Now, of course, we can do our grouping. We can take an 8x out and we're left with 2x plus 9. And we can take out a negative 15 and we're left with 2x plus 9. And of course, our factorised version is 2x plus 9, 8x minus 15. That would have been very tricky to do using any of the other methods that we've learned. So this little trick here, it's not really a trick, it's not a magic trick, but this little tip and trick here is very handy if you have a really, really genuinely difficult HQ to do. It will divide up that middle term. Once you've got that middle term divided up, then it's pretty easy from there on because you know that the grouping will work. You've rigged it that way. In my next video, I'm going to do some genuinely difficult HQs as examples and we'll work through some of those.